Um, Once again, welcome to the Linux programming and scripting class. Today we are going to continue with the looking at the tickle TK from where we left off. Let me first summarize for you what we talked about. In the last lecture, we talked about what is tickle, the tool control language. Essentially, it was developed by Osterhout in UC Berkeley. Again, it was originally developed as just a scripting language, mainly for just solving some of the difficulties with the existing scripting languages. So again, like that goes back to why we need tickle in the first place. The reason is essentially like this is one way to actually use it in applications, used to run applications as well as extending the various applications. So what we mean by that is we saw that in the last lecture that there are two things basically. One is on one side of programming is all the heavyweights essentially with very regular data structure and lot of complex programming, and it can take like years to develop and actually bring it online. Whereas on the other side we wanted very easy to use, highly interactive, quick development capabilities for scripting. The former one essentially like where we have like very complex, we can write very complex programs with very highly developed data structures, are languages like C, C++, etc. But on the other end, if you want to like write just quick scripting, that's where the tickle falls into. But one thing to understand is actually the tickle by nature is it can actually it's platform independent. That's how the tickle was developed. So multiple applications can be easily connected through by tickle, as well as you can extend an application for new user controlled ideas or user generated ideas using tickle. And then we also saw like how can we use tickle. So essentially it falls under this bucket as to how do we extend and how do we use the various applications tickle. So today tickle is very popular. It is used widely in many applications. You name any commercial tool today, it has a tickle interface, and you can use tickle to interact with the tool as well as extend its capabilities. One thing that we will talk about in this tickle class is also the Synopsys toolset, which you will be using extensively. And Synopsys toolset are also the entire toolset is built on tickle, and you can use tickle scripts to communicate to the tool. So this is tools like design compiler or IC compiler, things like that. We can easily use tickle as an extensible language. Today it's not just limited to that Synopsys tools, but other commercial tools also use tickle as their backbone. So today we will be talking about the more of the language constructs of tickle. So before we go into that, I wanted to just give you a brief background on to how all the commands are constructed in tickle. So there are two parts of learning tickle. One is the syntax and substitution rules. We saw this one. The substitutions are simple but may be confusing at first. So we will deal with this. And then the second one is all this built-in commands. This can be learned individually as needed, and then the control structures are actually command, and it's not language syntax. So essentially, like in tickle, even the control structures we will see are just commands. So we don't treat anything differently than any other command. What that means is, say, like if you write a command, for any kind of specialized application, they also fall under the similar treatment as any other command, basically like if then else, which are like built-in commands. So again, we call this as not control structure but just built-in commands. So we will see like how tickle program looks like, or what is the structure of a tickle program, and then we will go into more details. One thing to note is tickle has no fixed grammar. So essentially it's all like there is no like a lexical convention as to how you have to program it. So again, going back to basics, tickle script is just a sequence of commands. The commands are separated by new lines, semicolons, and then essentially a tickle command itself, like so now you look at the script is comprised of commands, and the command terminations are new lines or semicolons. Now the tickle command itself, each command can have one or more words separated by just white space. So the white space has meaning in tickle, and then always it is taken as the first word as the command name, and all others are arguments, and the command always results in a string. So those are the things that you need to understand and you need to keep in mind. And whenever we talk about any commands, just think about these two basic concepts. Number one, a tickle script is nothing but a sequence of commands, and then the commands are separated by either new line or semicolons. So these are the only command terminations. So if you don't terminate it with a new line, it still continues as a command. So we will see like some examples as to how this plays out in the real world, because there are these concepts are also like confusing with respect to like say a language like Perl, where only the semicolon was the main the main terminator of commands. And then tickle command, again it's one or more words separated by white space. So again that's another key difference and very important. In other languages you don't need to separate by white space, and even the various characters have special meanings, and basically that's used as a parsing mechanism. But in tickle it's very simple, basically like the white space is treated as a word separator, and then the command actually has just a number of words, and the first word is always the command name, and then the remaining ones are all arguments, and it also returns a string value. So here is one example. This command is set a and 22. This is the same as a equals 22 in Perl. Notice that there is no space here. We don't need to have any space between. You can actually say like $A. Yeah, actually that's more makes sense. So dollar in Perl is a variable, and then the assignment is assigned to 22 with the terminator as semicolon. Whereas here there is no dollar here, and 22, and there is no termination semicolon. And then another very short Perl program puts hello world. So here notice that actually like puts is the command name. It has only one argument right now, which is inside this quote hello world. So it just combines all of them and then just outputs that. So I think so far so good. So let's move on. So in terms of how a command is parsed, basically there is a division of responsibility inside the tickle parser. The tickle parser has two components. One is the tickle parser itself, and then the other one is a command procedure. So they go from the concepts that I talked about earlier. So understand that this line is your tickle command essentially. It's just a string of characters that are coming one by one. The tickle parser, all it does is it chops the commands into words. So this is one long command. It basically like takes it and then it basically chops it into first word, second word, third word, fourth word, and fifth word. Now, so mainly it also makes some substitutions. This part of it we will come to it. It does not interpret any values of words, so it does not assign anything, and it is a single pass operation. So every command, basically the command, you know that it is separated by either a new line or a semicolon. So it gets all these things that forms this command, and then when it goes through the tickle parser, first it just breaks it into multiple words based on just the white space character. So I'll just say blank. So it based on the white space character, it just splits it into all these words, and then it just sends these things to the command procedure, which essentially interprets these words as commands, whether it is there. And then once the first one actually like as the command and the remaining ones are arguments, it takes in and then it processes, and then it produces a string result, and then that result is what is stored here. Now let's look at all these other things basically, like how this entire process works. So once again, just to recap, there is a division of responsibility inside the tickle parser. The parser, the true parser, basically once it gets the command, which is separated by the new line or a semicolon, it parses and it actually separates the whole command into multiple words. This chopping is based on just that blank space basically that we say, and it also makes some substitutions, which we will see what it is. It does not interpret value of the words, and it is a single pass operation. Then once it chops up the words, it sends it to the command procedure, which interprets the words. It can invoke the parser recursively, meaning if you have something that's another command, it can actually like then go back to the tickle parser and expands that and then gets it. And finally it produces a string result, which is actually shown here as another string. So now let's talk about some of the things. First of all, there are arguments, which are after this one, all the remaining ones are the arguments, right? So the parser assigns no meaning to this argument. So here you can say like, okay, in C program, x equal to 4, y equal to x plus 10. Then y is actually 14 because this y is evaluated and then basically like the value is kept. Whereas in tickle, if you say set x 4 and set y x plus 10, the x plus 10 is just retained and basically you just get that same. And the different commands assign different meanings to their arguments. The type checking must be done by the command themselves. Again, we will discuss this in more details, but the commands themselves has an onus to see whether they are of the same type and if they are of compatible types and execute. It does not go back to the language to provide any kind of guidance as to what it is. So here we have a set of commands. First one, set A 112. Then we have another command called expr, which actually evaluates an expression, and we can see actually that there is a fixed point number and a floating point number. So now how does this get interpreted? So now the third one is basically it's an eval. Eval has a string as an argument, and in this example, the button.b, it has many arguments actually. So button.b has dash text as an argument, hello is an argument, fg is an argument, and red is an argument. And now another command called string, which has an argument of length and then another kind of a string, but we don't know what it is, but it's just another word. So the string has two arguments. So now this one has two arguments. This has actually three arguments basically, and then you have this has only one argument. This one has 1, 2, 3, 4 arguments, and this one has just 2 arguments. And they are all of different types. So this is a string of one type. Here there are string arguments, and all these are also like string argument. Here there is another string. This is a floating point and a fixed point. This is a fixed point. So again, how to distinguish and how to make sure that they are all consistent is left to the particular command that is that is getting those arguments. So we will see like some of these examples as to how commands will interpret certain arguments. Now we come to this variable substitution. There are two main topics in Tickle that you want to understand, and once you understood those two concepts, I think like life will be pretty much easier. The number one is the variable substitution. Number two will be the command substitution, and this is something that we will talk about in a later slide. But today, right now, let's talk about the variable substitution. So the variable substitution, the syntax is dollar followed by the variable name. Actually, the dollar is what gives the Tickle to see that okay, this is a variable and I will substitute with its real value. And the variable name can be letters, digits, and underscores. It says basically like, I mean, it's a white lie. The main reason is like sometimes you don't put the digits as the first one, but you can we'll see how it is. So and then the other thing is basically like this dollar can occur anywhere in the word. So now let's look at some of the commands and what happens basically. So here, let's say we are setting B to 66. Now when we say like set A to B, the result is just B. Notice that this is another just a value. It's not the same variable. In order for getting this B as 66, what do we need to put? The key variable substitution syntax, which is the dollar. So now in this command, which is set A $B, now we get A as 66. Now what happens when we say like set A $B plus $B plus $B? Notice that even though like I mean our intention is like 66 plus 66 plus 66, you know, and evaluate that, we don't have any commands for evaluation. So it is just going to assign exactly the same variable, which is it substitutes every $B occurrence of every $B by 66. So the A will be a string which is 66 plus 66 plus 66. This is not the same as like 196. Okay, so please note that. Or actually 198 should be. It does not put it that way. It only like has the 66 plus 66 plus 66. So now what happens when we say like set A is $B dot 3. So this dot actually it's also applied. So here you get 66.3. Now what happens when we say like set A $B 4. Is this the same as 664? Actually, in this case, it just says that there is no variable, because now the 4 becomes part of the variable name, because you can see that actually the variable name is letters, digits, and underscores. So it treats $B4 as a single variable, and it finds that actually that is never defined. So it just complains about no such variable. Now the second aspect of it that I talked about, which is the command substitution. So for the variable substitution, the key character is the dollar. Now for the command substitution, the key characters are this square bracket. So any script which is embedded within a square bracket, it substitutes that or interprets that as a command and then executes that command. So essentially it is evaluating the script and then substitute the results. And it may occur anywhere within a word. So let's look at some examples here. So here set B is 8. So B is set to value 8. So that is the result here. And then we say like set A as expression $B plus 2. So now when we say like the square brackets and then we give another function name, which is or a command name, which is expr here. So that expr is now needs to be executed because it's kept under square brackets. So now it executes this command. So when it executes the command, it knows that B is 8, so it substitutes 8 here, and then it actually adds this also. So there is a variable substitution and now a command substitution as well. So now it evaluates 8 plus 2 as a command. So the answer is 10, and then that it assigns to 8. So here the result is 10. Now what happens when we say like set A B minus 3 is expression B minus 3. Notice that there is no dollar in front of B, so B is taken as just another just name, and this whole thing is a string. So it basically like it puts B minus 3 as a string, and then it also uses the space is as a string, and then when it comes to this square brackets again it substitutes the command essentially. So that is $B is 8 minus 3 is 5, and we get it as B minus 3 is 5 as the string that is stored in A. Okay. Now the words break at white space and semicolons, except there are few rules on this. Number one is the double quotes. The double quotes prevent breaks because the entire double quote is treated as just one string and then it is taken as one string. So for example in this one, in this example set A $X is X is $X and Y is $Y. This entire thing is assigned to A as noticed in the previous example. Only the $X is substituted, $Y is substituted, but this entire string is just assigned to A. So the words don't break here. Essentially, it's just one continuous form. Now the second case where it will not break is the curly braces. Essentially, the curly braces themselves is considered as one unit. Wherever you're using curly braces, it's considered as just one word. So anything between the curly braces is one word. I want you to understand this concept because we will revisit this over and over again later on. So that's another one. The third one is the backslashes, which quote special characters. So here set a word backslash empty with backslash and backslash dollar and backslash and space, this entire thing is treated as just one word. And then the backslash also can escape new line. So so when we say, like, I mean, when we end like 1 2 3 4 and then space backslash and then we go to 5 6 7 8, this is just considered as one word. This is 1 2 3 4 5 6 7 8 with no break here, or because of the backslash. Backslash is just escaping the new line, so it is a continuation character. Now one more thing is the substitutions don't change the word structure. So we here, as an example, we set this A as 2 words, and then when we say like set B as $A, it's not going to change the word structure itself. So this is as I treated as one word, it still be assigned to B. So there is no nothing there. Now let's look at some of the tickle substitution rules and parsing. One thing is the tickle substitution rules are fairly simple and are absolute. So here are some of the examples. So here we do set A 22 colon set B 33. This is okay because we have a colon, so that we knows that actually this is one command and this is another command. Now we have a command comment. Comment is always like preceded by the hash symbol, and here hash, this is the command. This is also okay because this happens in a new line and with the first character as the hash. Now when we say like set A 22 hash same thing, this is a wrong usage because there is no break, and basically now you can say that actually A is having like 2 or more words, and all these are arguments, but the set A can take only like 2 arguments basically. So this is really not a valid syntax and it comes with an error. To correct this one, we need to include a semicolon in between, where we are now breaking this into 2 commands, and then the second command happens to be just a comment line. Okay. So the bottom line is essentially the parser looks at the commands only once. Essentially, does not treat. Okay, now that there's a comment line starting, so maybe this is another command, and basically if it's treated as a command, it does not do that. And so as a result, what happens is we cannot write expressions in just single command. We have to use multiple commands sometimes. We will talk about one such example slightly later on, but I would like to give you and motivate you on that example. And one thing to note is actually like that particular kind of version has never been written as a single command, or we cannot find a way to write that as a single command. Sometimes things get hairy, basically like where we put this curly braces with square brackets. So the curly brace essentially is a way to that we saw earlier, that is to combine words into one here. It prevents the breaks, and then look at the square bracket within basically. So that is to evaluate that expression. So it's a command substitution. So now we'll go into the command syntax. So the tickle essentially like what we learned was the commands are words separated by white space. So as it's shown here, and the first word is a function and all the others are arguments. Only functions apply meanings to those arguments, and it's always a single pass tokenizing and substitution. And then the substitution can take two forms. One is a variable substitution, the other one is a command substitution. The dollar causes variable substitution or variable interpolation, and then the square brackets cause the command substitution or the command interpolation. To prevent the word breaks, we can use three main things, or you can also extend it to the fourth one. The first one is using the quotes that prevents the word breaks, and then we can use the curly braces that also prevents all the interpolations, and then the backslash escapes all the special characters, so including any word breaks. So this is another way that we can avoid the word break. And then another key thing that we are always talking about is that Tickle has no grammar whatsoever. So now let's look at some more substitutions. So here we can use eval for another level of expansion. So and then we can also use commands like format for complex arguments. So exec rm star dot o, basically this executes this particular command. So again, this itself is a command that takes two arguments, and then the first argument being another command that gets executed. And here we say basically like star dot o, no such file, because there is no meaning to the star dot o. And then if we say globe star dot o, that gives the two files which are in the directory, which is a dot o and b dot o. Now if you say basically exec rm and then execute this command also using the command substitution square brackets, yeah, it comes up with that, and then it says the no such file or directory, because it's treated as just one full word. So it tries to find a file name called a0.o space b.o, and it comes up with no such file. So in order to delete these two files in this directory, we need to use this eval function. So when we say eval, then we say exec rm glob star dot o. This works correctly, and essentially we can now remove these files. So eval is used as another level of expansion. And there are other ways of writing this also. I mean, this is like just using like just one line. You can also split this whole thing into multiple lines, and then you can also like execute the same things. Anyway, this is one challenge I'm going to give you, how to get this without using the eval but using multiple lines. So try that out. We can discuss in the next class. Now I want to talk about the Tickle expressions. Basically it is more C-like, int and double. You can think of this as integer and floating point. So we will see like how this works. the command variable substitutions all occur within the expression itself, and it's used in expr, if, and other commands. So what do we mean by the command and the variable substitutions, and how are these expressions done? So here is some sample commands. Set b 5, so the result is 5. Now we have this command called expr, $b times 4 minus 3, so the answer is 17 because it's 5. This gets substituted with 5, so it's a variable substitution. So that is 20 minus 3 is 17. Now we can also say, like, some logical operation which is $b less than or equal to 2, and since it is not, it returns a false value which is actually 0. In tickle, 0 is always false, and anything other than 0 is always true. So just keep that in mind. Now here we also say, like, some cost function, basically 2 times $b multiplied by a. Here you can see that actually it is the floating point number. It automatically converts that into floating point number because one of them happens to be the floating point number, and usually it calculates as any data type until the type changes. When the type changes, it keeps that the new type, meaning, and then the precedence is essentially, like, integer has the lowest precedence, and then the floating point has higher precedence in the expr statement. So if you put a floating point up front, everything is computed as a floating point number. If you put the floating point towards the end, then until that time it's computed as an integer, and then towards the end it is turned into a floating point. We will see some examples as to how this will affect. Now the other one is expr $b times fact 4. Now here you notice that actually, like, it's in between the square brackets. So this is command substituted. Basically it computes this fact 4, and then it replaces that with fact 4, and then times the $b. So here this is also like substituted. So it is 5 times 4 factorial, which becomes 120. So the bottom line is tickle will promote integers to reals when needed. All the values translated to the same types, and then here also, like, you can notice that actually the expr command knows about the types and the tickle does not. Tickle is still, it's just a collection of words. So imagine, right? So it's just a collection of words, and still it is very powerful. And today a lot of programs actually run with this. So now let's look at some more examples to understand expr in more detail. So the first one is fairly simple. You guys can answer 5 plus 6 by 2. So 6 by 2 is evaluated, which is 3, and then basically added to 5, we get the 8. Now the next one is 5.0 plus 6 by 2. Again, since this is a real number, everything is converted into real, and then we get an answer as 8.0, which is a real number. Now it gets slightly interesting. So now the next one is 5 divided by 2 plus 6. So it evaluates 5 divided by 2, which is actually 2.5, but since this is an integer, it leaves these two out, so it is just 2, and then when it adds to 6, it's again 8. Now this expression again, so if you look at it, basically it's again 5 divided by 2, which is 2.5, plus 6.0, but since when it computes this, it's still a integer data type, so it does not use this. Now plus 6 it adds, and then that becomes 8.0. Now the interesting thing is, instead of putting 6.0, I put 5.0 divided by 2 plus 6. Now you look at this, actually this is already a real number, so the answer also should be real, which is now 2.5. Now plus 6.0 will give you 8.5. So look at these two expressions, they are exactly identical, but those two have two different answers. So this is another caveat that you have to always adhere to when writing tickle programs. The data type actually changes as it goes. So if you have like a variable substitution all over, and at some point it turns into like a floating point, you get a different answer than if it was just a real number, if it's just an integer. Okay. So now let's talk about the tickle arrays. In general, since we are using strings and words and etc., the tickle arrays are always associative arrays. The index can be anything that you want. It need not be just a integer number. It can be anything that you want. For example, here set x Fred. So the array representation is x followed by the index. Here the index is called Fred, and we set that to 44. Now we say set x2 is this expression, which is $Fred, $x Fred. So here the command is the variable is substituted to 44, and then the command substitution happens because of the square brackets. So this expression is evaluated, and you get 50 as the answer, and that is assigned to x2. So now if you want to print out the names, so here the arrays are basically like this is the name and value. So to print out the name, we just say array names, and the array name is x, and it prints these two index, basically it's Fred and 2. So using this principle, we can actually fake two-dimensional arrays. We don't need to construct the two-dimensional array, but we can construct a single-dimensional array and then fake it as a two-dimensional array. How do we do it? Here is an example. So here we say set A1, 1 as 10. So it appears as if like A is a two-dimensional array with 1, 2, 3, 4, and then another 1, 2, 3, 4, and then we are making this 1, 1 as 10, and then 1, 2 as 11. But in reality, this is just one name. So 1, 1 is a name that has value of 10, and 1, 2 is another name that has a value of 11. So if you print out the array names A, then it prints out together, which is 1.1, 1, and 1, 2. So now we see that actually like commas can be included in names. So now let's look into one of the things that we saw earlier in more detail. This is the expression A, $A multiplied by cos 2 star $B, 2 multiplied by $B. So here actually this is evaluated. All these things are basically like $A and $B are substituted. So whatever this value that they get substituted, and then the EXPR is called after that basically. So it is substituted, and then EXPR is called, and then EXPR goes to cars and says that, hey, I don't know this value, so recursively that goes back, it gets evaluated, then it goes back to expression, and then you get this answer. So the difference here is, in this one the $A and $B are substituted by the scanner before the EXPR is called, whereas in this expression where we are saying EXPR, notice that this curly braces and $B star fact 4, essentially here the $B is substituted by the EXPR itself. The reason is because of this, and it needs to have like single word expression, so it basically substitutes this. So you get again 5 into these are also like substituted, so this is evaluated and you get finally 120. So the expressions can get substituted more than once. So here one example, set B is \$A, and then set A is 4, and then EXPR $B times 2. Now you can see that actually the B gets first substituted with this A, and then it looks at the A, and actually the A is also needs to be substituted, so it is actually 4 times 2 equals 8. And some tickle operators can also work on strings. For example, A is bill, EXPR $A less than and is going to be 0. And then the less than, greater than, less than or equal to, greater than, equal, and then not equal to, they can all work on strings. Only thing is, you have to caution yourself when the strings can also look like numbers. In general, the tickle is always like generating strings. So when it is generating a number, it can be just a string. And you can also use the string compare function to compare any strings. Now let's talk about the lists. The lists are nothing but 0 or more elements separated by white space. Again, key component is the 0. Essentially, it need not be just 1, it can be just 0. And here, red, green, blue. This is a list essentially because it has a white space in between. The curly braces and the backslashes are for grouping. This we saw earlier. So here A, B, C, D, E, F, and the C, D, E is enclosed in the curly braces. So this is treated as just one unit. So there are actually 4 words, which is A, B, C, D, E, and then F. Then we can also like use escape characters for grouping. So here one escape and then space and then word. This is grouped as 1. So this is 1, 2, and 3. Only 3 words. Then we have some list related commands, which are all these things: the concat, lindex, length, search, for each, linsert, range, sort, append, list, and replace. All these things are list related commands. And one thing to note is all the indices will start with a 0. The end means the last element. So here use this function called lindex of this array with 2. That the second one is actually it goes from 0, 1, 2, and 3. So the 2 is this big CDE expression, which will be output. and then when we do the L sort of red, green, and blue, it does an alphabetic sort. So to put this as 1, put this as 2, and then put this as 2. The lists actually are very powerful syntax in Tickle. We will learn more about list actually, and there are some specific commands that will also I will also go through for a tool like the synopsis tools. So a sample command will be set stack is 1, so that means that the stack gets 1. Now when we say like push stack red, the red is pushed ahead of 1, so 1 is moved to the end, and then red is pushed. And then if you say push stack a fish with curly braces, that gets precedence essentially as a curly braces, and then it puts the curly braces a fish as the first element, then red, then followed by 1. And if you pop the stack, then it comes up as just a fish because it's only like the first element is popped and then the remaining ones are kept inside. So now the stack has red 1, but a fish is popped out. And then the push and pop are very short and use list commands to do their work essentially. Now some more interesting facts about lists. The true list meaning won't change when it is rescanned. Now let's look at this example where the first $animal blue and $animal. This is not a list because there are variables here which may not be substituted. Now fish, blue fish, red fish, blue fish, this is the list. Now red escape fish, blue escape fish, this is not a list, but if you say just list red, this one, this gives you basically like red, and then it puts this as a one collection, and now this can be a list essentially, since that is a word. So one thing is that commands and lists are closely related. A command is actually a list, and use eval to evaluate the list as a command. So in summary, today we are learning more and more about Tickle. Two things I want you to take away here from this lecture are this variable substitution and the command substitution. The variable substitution is using dollar as the variable as the marker for the variable. Wherever you find like dollar variable name, it gets substituted with the real value. The commands themselves are it identifies the command with the square brackets essentially. So then it substitutes these actual scripts whenever it finds a square bracket and then evaluates that result. And then one other key thing that we saw was how does Tickle recognize the words essentially. We know that actually like words are distinguished by where they break essentially, so they break with white spaces or semicolons. But there are some exceptions to the rule. One is the double quotes prevents breaks, curly braces prevent breaks and substitutions, as well as backslashes can quote the special character and thus eliminate the word separation. So words break. So this is another key thing that we saw. And then in the commands, actually the first word is always the function and the others are arguments. and only the functions apply meanings to the arguments, and everything is done in single pass tokenizing and substitution. So something to understand in EXPR is EXPR command, basically it scans from left to right. It uses the same arithmetic evaluation technique. Only thing to note is essentially whenever it encounters any argument which is a floating point, from that point onwards everything is computed in floating point. So this can cause some serious headaches when you try to program, and I want you to be aware of this when you write your own ticket programs. And then we also learned about lists and how to use the lists. We will revisit again in the next lecture. So I think that's pretty much it. Thank you very much. Thank you for listening.